Okay, I won't be using full screen since um, it conflicts with my recording software, right? So instead, I'll be changing the size of the window because sometimes when I'm recording and when I change tabs, the uh, the shared tab would be blacked out, and consequently, in the recording, it would also be blacked out. Right? So um, just bear with the size for now. But of course, I will be sharing the PowerPoint in the VLP so that you can go back to this later. But of course, the important discussion would be done in the Google Meet. So I hope that you are listening intently, especially on the part where we're covering the education part of the lesson or of the course. Okay, so let's start. Okay, later na lang kay Mr. Clavero. Okay, so for week 1, we'll be handling the K-12 Science Curriculum Guide for Science. So this is readily available in DepEd. Right? You can just download this for free. Of course, it's a public material. And before we tackle the different topics in science, in physics and earth science and space science, right? So in your Sci 1, I assume that you have covered chemistry and biology, right? Okay, so any hand? So can we clarify that or verify that? So in your Science 1, so teaching science in the intermediate grade for chemistry and biology, right? You have covered chemistry and biology subjects in your previous subject. So can I get some?
Yes, sir.
Okay, right. So that's correct. Okay, so this one, as the subject code implies, it's Science 2. So this would be a continuation of that subject. However, we would be covering the physics and earth and space science part of the K-12 curriculum. But let me ask, has the actual K-12 curriculum guide has been covered in your Science 1 subject or not yet? Or was it skimmed over? So was this discussed, the one from DepEd, or not? So can I get any clarification from the class? Were you able to cover the K-12 curriculum guide for science or not? So any hands or maybe in the
Some
chat
po,
box?
sir.
Okay, some. Okay, so let's just take this as a review, okay? So what is our goal here? So it can be summarized in a single sentence. Right? So the what's, the hows, and the whys of teaching science in the elementary level. Although for our course title, it's in the intermediate grade, but science is covered from grades 3 to 6. Right? But when you say intermediate grade, it's from grades 4 to 6. So we are lacking one grade level. So to complete that, I designed our course outline to cover everything so that you won't feel missing out when it comes to the actual field, right? Once you have graduated, and of course once you have started reviewing for your lead exam. Okay, so what are the course requirements for our subject? So there's only 3. Since it's only face to face, and I think it's in the I guess culture of this school, right? The attendance is not part of the grades, but of course you would be missing out on the actual discussion, right? So yes, it is not required. However, you are highly encouraged to attend. Otherwise, you would be missing out on the actual discussion. Okay, so what are the 3 requirements? So for assessment 1, it's the lesson plan. Were you able to write a lesson plan in your other subjects already, or I would assume that's already the case, right? Since you're already in third year. And the second and third assessments, so this would be the face-to-face teaching demonstration with lesson plan. So unlike last semester, right, the teaching demonstration was usually online. However, since we are slowly transitioning into a face-to-face classroom setting, I would like to prepare my students for the actual face-to-face teaching situation. Since you're now in third year, so you'll only have like what? Next year, you'll be fourth year, and after your fourth year, once you have passed your board exam, you would be teaching in the schools, right? And at that point, by 2023, schools would be majority are in face-to-face, right? In fact, in Metro Manila and Quezon City, majority of the schools are already conducting face-to-face classes. However, here in the province, I'm not sure why we are slow in implementing face-to-face classes. Okay, that's why I want to prepare the class for a face-to-face session. As for the schedule of the face-to-face session, okay, let me switch tabs again for the calendar that I'm using. Okay, it's this one. Okay, so you will be also seeing my workload. Yeah, it's very both exhilarating and tiring. Where was it? Okay, this one. Okay, as you can see here, right, we're going to compress sessions. So weeks 1 and week 2, we're going to cover it here. But again, depending on the length of discussion, we'll adjust the topics. Okay, but our main priority is, of course, the part on education. For the actual science content, we'll just breeze through it since it's on the elementary level. Alright, in terms of discussion, it will just be very fast. We would have some activities for activities to be answered on the level of elementary level. So again, the difficulty of those subjects, or rather of those topics, are quite easy. But when it comes to, let's say, the methods, the approaches, the strategies, that's where we have to get into the nitty-gritty part of the lesson or of the discussion. Okay, so this right now we're on week 5, right? Yeah, last week was week 4. This week is week 5. Next week is week 6 actually. However, the week 6 is supposed to be the assessment week, right? But since we started late, we'll be having that on week 7. Okay. However, in our case, in Science 2, our assessment 1, 2, and 3 are, let's say, it won't follow the actual schedule, right? Since for assessment 1, you're just going to be submitting lesson plans, right? And I'm going to check them, critique them, and then submit, or rather give them back on the next meeting. Although if we do have the time, it would be much better if we have a face-to-face evaluation or critiquing, or maybe just a one-on-one critiquing of the lesson plan. But usually that would take me like 20 minutes per student. Okay, depending on the time, right? Maybe on a Saturday we can schedule it. Okay, so this is week 7, then week 8, week 9, 10. Okay, so on week 10, on October 29, this is our tentative schedule for our teaching demo, our face-to-face teaching demo. However, I'm still writing the proposals due to the budget. Can I don't have any drawing materials. So the setup would be, we will be using 5 classrooms, or borrowing 5 classrooms, and each classroom would have 8 students. So we'll start from 8 o'clock, one student, 1 hour, 40 minutes of 40 minutes of teaching demo, 20 minutes of critiquing from the, of course, from the critics. So that's 8 to 9, 9 to 10, 11 to 12. Wait, is that correct? Yeah. 8 to 9, 9 to 10, 10 to 11, 11 to 12. So that's 4 in the morning, and then in the afternoon, 1 to 2, 2 to 3, 3 to 4, 4 to 5. So that's 8 students per classroom. Although we have 40, sorry, I think we have 42 students, right? So we have 42 students. 2 classrooms would be unfortunate enough to have 6 students, right? So they would have to extend a bit for their class session, or then again, depending on the length of the teaching demo and the critiquing, right, that would be adjusted accordingly. Okay, so 8 students per classroom, and then as for the number of critics, ideally there should be 3 critics per room, right? Why 3? So that there's a tiebreaker, and I won't be one of the critics because my specialization now is in andragogy, right? Not pedagogy, right? Because when we say pedagogy, that's teaching of, well, younger students. But for college, we're dealing with andragogy, right? So we're dealing with adult learners. So my relative experience and expertise would technically not be in the elementary part, right? That's why I want to invite elementary teachers, preferably public school teachers, so that when it comes to the actual teaching demo, they're the ones who are going to give you the appropriate critiquing. So that's my idea behind our assessments 2 and 3. So that's October 29, and then on December, should be around December 7, right? On December 7, oh sorry, that's January. On December 10. So December 10, that would be your final face-to-face teaching demonstration with lesson plan. Ideally, I would be getting the same amount, the same critics, so that they could say, okay, you have improved on this field, or on this part of your lesson plan, or on this part of your teaching demonstration. Right, so we can have some consistency of critics. Otherwise, if you keep switching the critics, there might be some conflict of, well, let's say, information. So as much as possible, I would want to invite the same critics again twice. So that's the problem, right? So we have 3 critics per rooms. However, there's 5 rooms. So 3 times 5, we have 15 critics. And we have to invite them twice. So that means it's essentially 30 persons, or 30 critics, quote unquote persons, as in, rather, we're going to borrow them twice, right? So that's 30. Technically, times 2 again, since I have another science 2 subject, right? As you can see here, on Fridays in the morning, 7:30 to 10:30, they would have the same assessments, right? 1, 2, and 3. So that means 60 quote unquote critics, right? Or 60 sessions, or 60 hours. Or is it 60 hours? No, more than 60 hours actually. So that's why the budget would be troublesome. Right? I think the estimate was that we're going to reach 15,000 in terms of snacks and lunch. So yeah, that's why I have to fix the proposal. Okay, that's the ideal scenario, right? Okay, So that's going to be our requirements. Right, so lesson plan for assessment 1, and then teaching demonstration for assessment 2, and then a final teaching demonstration for assessment 3. Okay, where's the tab? Wait, where's the PowerPoint? Is it this one? Okay, here. Okay, so far any concerns regarding the course requirements? Of course, the rubrics would be uploaded in the VLP. So far, any concerns about the course requirements? Okay, none. Right. Okay. Hopefully that's ideal. Okay, so let's move with the course outline. What would we be learning in our subject? So of course, the K-12 curriculum guide. And after covering that, we would be tackling grades 3 to 6, physics and earth science, and space science. Well, essentially astronomy, right? However, when it comes to numbers 2 to 5, we're not just going to handle the content, right? We would be also doing some activities by, let's say, emulating the difficulty level of grades 3 to 6. That's why we'll be doing a lot for this subject, right? So as going back in our course overview, the what's are the content, right? What topics we're going to cover, and the hows would be the methods and strategies. As for the whys, we'll be covering that shortly in the science K-12 curriculum guide. So that covers the 3 essentials of our course. Right? So if you're fond of reading mystery books, right? We got the why done it, how done it, and then the who done it, right? So here, our important part are the hows, right? How do we teach science in the elementary level? Although there's a book actually regarding teaching science in the elementary grade, however, it's only volume 1. So when we say volume 1, it only covers chemistry and biology. There's no volume 2 covering physics and earth and space science. So majority of this content would be made by yours truly. So I won't have any sort of guide in teaching this. Although I did teaching science in the elementary grade before, and this was way before we have the book from Lorimar, right? Okay, let me show you the book instead. Let's open up. Okay, I think I can open up Google here. Okay, Google.com, Lorimar Publishing, Teaching Science. Let's switch. Okay, opening the file. Okay, this one. Okay, let me switch to presentation again. Okay, so this is the book for part 1 of teaching science in the elementary grade. However, this only covers chemistry and biology. So we would not be using this actually, sadly. I'm not sure in your science 1 subject, were you introduced to this book or not?
No.
No, okay, right. Actually, this is quite new. This was published last 2019, and I taught teaching science in the elementary grade in my previous school. When was it? Let me check my documents. I taught this last. Was it on the second semester? Yeah, second semester of 2018 to 2019. So this book was not yet published. So when I handled the course, it was Well, I would say similar actually. However, less focus on the content, since again it's elementary level. It would just be a sort of recap. I was focusing more on the methods used on teaching science in the elementary level. Okay, let me try showing you my course outline back then. Okay, was it this one? Wait, not this one. Oops, not this one. Wait, okay, wrong file. Oh, I think this should do it. Okay. This one. Let me again change the tab. Okay, let's change the window. Use this one. Okay, this one. Right, so we can see how the subject evolves. Although it is quite similar, actually. However, when I taught this one, it is much more compressed since they did not separate chemistry, biology, and physics and earth and space science. So this one is more compressed, unlike our topic right now, where we have a lot more, I would say, time to absorb topics. So as you can see here, okay, let me just alt-tab this one. As you can see here, okay, so invitation to teaching science. So of course, this is the course overview. So K to 12 curriculum guide and science for primary grades. So essentially this one, right, or rather what we're going to cover later. Assignments, well, for them, right, back then would just be reading topics from grades 3 to 6. That's why in here we covered, well, in 2 weeks the entire grades 3 to 6, right? That's why in one session we have several activities at once, and it was a bit I would say taxing. So that's why 3 to 4, it's 2 weeks. So the entire chemistry, grades week 5 to 6, okay, biology, grades 3 to 6, 7 and 8, okay, new topic. So for example here, methods in teaching science. So yeah, it's a bit long actually compared what we're going to use. Although as for their requirements rather, it's actually the same on what I'm going to give the class or assign for the class, right? So lesson plan, teaching demo, or 2 teaching demo rather. Okay. So going back here, okay, course outline, of course this one. Okay, now for the actual discussion, okay, so this is now our lesson proper. So in the science framework in the K to 12, we have 3 components. So we have number 1, understanding and applying scientific knowledge. Number 2, developing and demonstrating scientific attitude and values. And number 3, performing scientific inquiry skills. So later on, we would be covering this component by component. So when it comes to these 3 components, these are essentially our, let's say, sort of guides in how should we handle science subjects. Okay, as for the goals, the elementary students should be able to become, okay, a critical and creative problem solver, a responsible steward of nature, an innovative and inventive thinker, an informed decision maker, and an effective communicator. So likewise, we'll also be covering this bit by bit, right? Goal by goal. As for the learning theories, we do have 7. So take note when it comes to the differences in approaches, models, methods, strategies, they're all different. Okay, let's try making a new diagram here. Okay, let's remove this part. Okay, let's do some caption. Let's have some. Wait, no, I think I have a picture here. Okay, a bit of. Where is it? Okay, this one. Okay, so when it comes to, let's say, the framework in methods, in approaches, they are in different tiers. And even above this, we have the VMO, the vision, mission, objectives of the university. And then lower than that, we have the different VMOs of the colleges. And going a bit lower, we have the course programs, right? For example, for BEd program, there's an actual let's say vision or mission as well, or the goal or the objective on what should the student be able to achieve once they have taken the subjects for BEd students. So going down the program, you now have the individual subjects. For the individual subjects, of course, you have the course descriptions, the objectives, and going a bit lower, we now have the principal, where this is the, let's say, where the differences would be, let's say, what's the proper term, would be noticeable between each teacher, because each teacher would have a different principle approach on a certain subject, and those principle and approach would also influence what strategies and method they should use. Although technically on this diagram, method should be a bit higher compared to strategy. And then of course the technique, these are the different nuances of the teacher already. Okay, so how does the framework look like in K-12? Okay, let's zoom this in. Okay, zoom in. Okay, so let's go down here at the bottom. On the 2016 K-12 DepEd curriculum guide, there's actually eight approaches in learning. However, in the book Teaching Science and Elementary Grades, there's 7. So I'm not sure why brain-based learning has been removed in the curriculum or rather in the framework, even though I'm using, or rather I downloaded the file from the official DepEd website. So maybe there has been some changes that has not been reflected in the website. We would also be covering, let's zoom in here. Okay, these 7 approaches. So multi-interdisciplinary approach, STS approach, problem issue based learning or PBL, inquiry-based approach, constructivism, social cognitive learning model or cognition learning model, and the learning style theory. So we won't be tackling brain-based learning. I would assume this has been phased out due to the changes in the field of education, right? Since education is also evolving, as just like with science. And then as we see here, right, we do have the 3 components that we have stated a while ago. So understanding and applying scientific knowledge, developing and demonstrating scientific attitude and values, and demonstrating scientific inquiries and skills. And surrounding this, we have the different goals that the student should be able to become once they have undergone the entire K-12 curriculum. So let's say they are now a critical thinker, a problem solver, a student of nature, etc., etc. We should now be able to tell them that they are now scientific, technological, and environmental literate. Okay, so how can we say that they are these? So we refer back again to the goals of the K-12 science curriculum. So this is where our discussion would revolve. Okay, so essentially this is the outline of the entire K-12 curriculum, right? You have here the approaches, the components, and the goals to achieve a scientific, technological, and environmental literate student. So what are then these components? So components of scientific and technological literacy. Of course, the environmental part as well. Okay, so on the first component, so understanding and applying scientific knowledge. So what do we mean by this component? So science consists of two things: a body of knowledge and the process by which that knowledge is produced. Usually, when I say science, right, it's usually, it's usually, okay, this part, right, a body of knowledge. Rarely, or not rarely, rather, okay, I guess, yeah, we can say rarely do we look upon the actual process on how knowledge is produced, or knowledge, or how knowledge is acquired. That's why we have the scientific method, right? Usually on grades 3 or maybe even earlier, elementary students learn the scientific method. And even in your high school, right, as with spiral curriculum, you have been reviewed on, okay, what is scientific method again, right, on a much deeper learning, or rather on a much deeper level. Okay, so scientific knowledge is not absolute or certain, right? We always have new advancement in science, right? That's why we have publication of journals, theories, books on sciences. Like one of the famous example is the heliocentric and geocentric beliefs of the solar system. So way back then, around, let's say, before 1400s or maybe even earlier, people used to believe that the Earth is in the center of the universe. But of course, with the advancement of science, we know that's not the case anymore. Right? We're now in a heliocentric model of the solar system. So meaning, helio, right, the sun, is on the center of the solar system. Okay, so knowledge, including facts, theories, and laws, is all tentative and subject to change due to the new evidence brought about by advances in theory and technology. So science is also socially and culturally embedded. I would like to emphasize this part. So science is also socially and culturally embedded. Okay, why is that? Now, when you are writing your lesson plan or designing your lesson, if you're going to use example, make sure that it is something, let's say, authentic, or something that is close to their environment. Although for college students, I would use, of course, let's say, books by Western authors, because they are usually much better than Filipino authors when it comes to sciences. But of course, science really does not change whether you're here in the Philippines or you're in another country. However, when it comes to elementary students, context is important because it's easier for them to visualize problems that are something that they can see, or something that they can experience. Like for example, if we're going to discuss the weather, usually in elementary, we do discuss winter season. However, we would want to say, okay, however, in the Philippines, we only have two seasons, right? The rainy season and then the hot season. However, on a higher level, let's say college or even high school, right? We introduce with, of course, the four seasons. So we have summer, spring, autumn, and winter. However, here in the Philippines, right, we don't necessarily experience those four seasons, right? We do have summer. Our winter is technically rainy season, right? So we have to emphasize the differences in examples. Okay. By the way, if you have any questions, just raise the hand in Google Meet, right? So you're free to raise any questions regarding the topic, of course. Now, what about for the different scientific attitudes and values? So we have 10. Although, of course, if you're going to look up in Google, it might differ, but usually they should share the same number of, sorry, not the same number. They should share similarities when it comes to these attitudes and values. So that number one, curiosity. Of course, we want the students to have an inquiring mind. Right? We want them to be questioning what they are seeing, what they are hearing, what they are listening, right? Essentially questioning their existence, so to speak. That's a bit more philosophical, but essentially that's what we want to let them experience, right? We want them to question their experience. Like for example, questions posed by elementary students are usually a bit more, I would say, primal. Primal in a sense that it's very basic, that it's hard to explain it in simpler sense. Like for example, an elementary student may ask, "Why is the sky blue?" Right. Of course, the correct answer is that due to the reflection of the ocean. However, how can you simplify reflection when it comes to the students? Right? You can say, or rather, we can say, okay, think of the ocean as a mirror, or rather, not the mirror. Yeah, let's say think of it as a mirror, and wait, no, yeah, that's the difficult part, right? Of teaching, or rather, of answering some question proposed by elementary students, especially much younger students, right? Because you have to explain it in a sense that they should be able to understand it. For example, rather the example that we used before, they know what mirrors are, right? But they don't know what reflection is. Since reflection is usually discussed at what level, like high school, right? Or maybe grade 6. So we'll have to think of several ways on how to simplify such answers. Okay, and then humility. Now, when we say humility, this is what we mean by students accepting that they might be wrong in their answers, so that they would be able to improve on their skills, on their abilities, right? So admitting failures. What about for open-mindedness? So when I say open-mindedness, it is for a student to listen and respect the ideas of other. For some students, for elementary students, right, if you have some younger siblings or younger relatives, right, they could be brutally honest, right? And due to their honesty, they could be quite insensitive to the feelings of other people. So that's why you have to inculcate, sorry, is that the proper term? You'll have to emphasize that whatever they're saying might hurt other people. At the same time, whatever other people are saying to them should also be um, taken not at a surface level. Like for example, if you say a student is wrong, right, they might take it negatively. So that's why you have to be very careful with your words, especially to younger students. In fact, when it comes to teaching elementary students, we don't say explicitly that you are wrong. Even in high school, right, we don't say that your answer is wrong. We say, okay, how can you improve that answer better? Or you can try using a scaffolding question to lead them to a much better answer. Or by using facial expression, right? You are furrowing your eyebrows or using audio cues like audibly sighing or audibly humming, like is that correct? Or just simply humming, right? Just like that. So we don't explicitly say that the student is incorrect or they are wrong, right? Because again, we might hurt their confidence. The number 4, intellectual honesty. So it is for them to say that their work is not copied, right? They did not cheat their data, or they did not copy their answer, right? Because in the actual scientific field, we have, well, of course, in journalism as well, right? We have plagiarism, and plagiarism is a very serious offense. In fact, let me share some experience, or rather a story from one of my teachers in my masteral class. In UP Diliman, there has been a case of plagiarism that they have to what's the proper term? Approach the tribunal. I think was it the tribunal? Approach the tribunal to carry sanctions on the students who plagiarize another journal or another work. So what happens to the students? They were expelled due to plagiarism, right? Because in science, right, our journals or experiments, these are extremely hard work, right? And we don't want well, not just in science, right, in any sort of hard work, you don't want other students or other people to take credit of your hard work. That's why intellectual honesty is very much treated seriously. So that means for students, for elementary students, okay, they might not what's the proper term? Understand the severity of cheating, right? That's why you have to say, usually, right, for kids, we use the golden rule, right? Okay, what would you feel if somebody copied your homework, right? That's usually one of the easiest way to get some reaction from your students, from your elementary students, right? Because golden rule is usually for students, for elementary students, it's based on emotion, right? So if somebody hurt you, what would you feel? Okay, you would feel sad, you would feel hurt. So why should you not hurt other people instead, right? Because you would also they would also feel bad, or they would feel sad, right? So a simple way of teaching students on how to wait, sorry, I'm running out of vocabulary, on how to inculcate, let's say, the feeling of wrongness. Okay, as for perseverance, of course, we want to reward hard work and of course persistency, especially in science, right? When it comes to experiments, sometimes things would go wrong, so you should tell them that okay, it's okay to mess up. So what have you learned from that? So what can you do next time to achieve the goal properly, or what can you do to not make the same mistakes? Okay, skepticism. So for skepticism, it means that we don't want to jump conclusion fast. Like for example, you're observing something, so you don't say that it's correct. You should ask first question. Okay, what if I try another angle? Would I reach the same answer? Right, that's why we have trial and error, doing different experiments to achieve the same hypothesis or conclusion. Right, so that's skepticism. And then for creativity, so actually creativity and innovativeness, they're actually quite similar. So in some books, or maybe over the web, creativity and innovativeness might be shared in one number. So when we say creativity and innovativeness, this is for the students to learn on how to approach a problem with new solutions. Right? So that's our key term there, new solutions, right? Something that they have think of by themselves, and that's something that they have look up over the web or over the internet, especially with the access of with the ease of access of the internet. Right, it's very easy for students to just Google the answer, right? So that's quite that's actually limiting their creativity, because they're simply looking for answer instead of thinking up of a solution to arrive at an answer. Okay, for rational, so that means we want the students to use logical thinking before giving an answer. So quite similar to skepticism. So once they have arrived at a conclusion, right, let's say using a hypothesis or using an observation, they should prove that by following certain scientific methods, right? Again, using experiments. So that's what we mean by rationale, right? Can these hypotheses be proven or disproven by scientific method? The number 9, objectivity. So that means you don't want the students to have heavy bias on their answers, especially on their conclusions. Although of course, as humans are political creatures, right? We do have bias internally, so that's very hard to remove. So we want the students to train themselves to remove their bias from their conclusion. Usually for students, their bias would come from experience, right? So usually if their experience is different from the observation, they might not readily accept it. Of course, that means they do have a healthy dose of skepticism, but at the same time, we want them to be both rational and objective. So does your experience line up with the observation? So how can we prove that? So again, we apply the scientific method. Okay, the number 10, innovativeness, of course, approaching new, or rather think of new solutions to approach or to solve an answer, or to solve a question with a new answer. Okay, so these are the 10 things that you'll have to keep in mind when you are designing your activities for your students. For elementary, right, if I'm going to be checking your lesson plan, I would be critical in how you do your activities. And when it comes to the discussion itself, right, due to our advancement in education, we want it to be student-centered. That means more interaction from the students, right? We don't do lectures. Although in of course in college, right, we do lectures because we do have to compress lessons. We do have to essentially absorb an entire book in a single subject. Right. Then again, andragogy is different from pedagogy. So that's why in your methods class, what we are teaching is quite different from what we are doing. Okay, so again, we want to separate what we are experiencing in the college setting and what we want to do in the elementary setting. So we want to have teaching demos often, since our critics would be actual public school teachers. Okay, right, that's our main goal there. Okay, so that's the second component. What about for the third component? So for the third component, so performing scientific inquiry skills. So essentially, this is what we want the students to develop as well, right? Although for elementary, we're actually quite in the middle, right? Grades 3 to grade 6. So that means you want your students to develop all of these skills. Then again, depending on what grade level you are teaching. So for kindergarten to grade 4, ask questions about objects, organisms, and sorry, that should be plural. Organisms and events in the environment. So putting it on a higher tier, so for grades 5 to 8, identify questions that can be answered through scientific investigations. And then another skill, plan and conduct a simple investigation. So for grades 5 to 8, instead of planning, we want them to design a scientific investigation. So take note of the term scientific. So that means there has to be actual steps and could be replicated. So that's another term that we want to emphasize on scientific investigations. They should be they should be replicable, or they could be replicated by other people. And then another skill, employ simple equipment and tools to gather data and extend the senses. So on a higher tier, so we want them to use appropriate tools and techniques. So of course, by grades 5 to 8, so almost high school level, they would be exposed to laboratory, right? They would be using a bit more appropriate apparatus. Like for example, you want to measure something. For grades 3, 4, they might use the ruler, right? But what if they would have to measure something that is quite long? Or rather for elementary, you should not let them measure something that is more than 1 meter, right? But for grades 5 onwards, okay, you want them to measure, let's say, larger objects. So let's say you want to measure the length of the classroom. So instead of using ruler, of course, that would be inappropriate. You let them use the meter stick, or maybe even you let them use the tape measure, right? Or the tape measure for the engineers. Then another skill, use data to construct reasonable explanation. And then we're going to upgrade that to develop descriptions, explanation, prediction, and models using evidences. So in here, when we say models, we mean by equations, right? So of course in physics, we do have some equations already, simple equations, but for grades 3 and 4, usually it's listing data, right? Recording, etc., etc. So they don't have yet to, they don't have the capacity yet to derive equations. And then lastly, communicative investigations and explanations. And they're going to upgrade that to think critically and logically to make the relationship between evidence and explanation. So quite similar to the spiral curriculum, right? Their skills are much more, or are simpler from kindergarten to grade 4, but once they arrive in grade 5 onwards, their skills are much more refined. So that's why it's from a simple skill to a much more complex skills. So likewise, again, you have to be mindful of the the grade level that you are teaching. So for example, you're teaching grade 4 and grade 3, right? Don't give them activities that would require them to do skills that are from grades 5 to 8. Likewise, if they're grades 5 to 8 and then you give them a very simple activity, they would not be motivated, right? They would be bored and flat. For grades 3 to 4, if you give them difficult activities, they would be frustrated, right? So that's essentially the application of flow theory by Mikhail Csikszentmihalyi. So if the difficulty and then their level are not on the same level, they would not achieve the flow, right? They would be bored, or they would be apathetic to the activity, or they would be frustrated if it's too difficult. And then next we have, now what are the different approaches, models and practices so that we can achieve these 3 components? So how do we let students become or have understanding and applying scientific knowledge? How do we let them develop the scientific attitudes and values? And how do we let them develop the different inquiry skills? So we want to know the different approaches, models, and practices used in the K-12 framework. So take note, these are approaches and models. As for the actual method itself, we use the 7 E's method. So later on, probably by the next session, since we're only like half of the PowerPoint, we'll cover the 7 E's. Alright, so in your lesson plan and in your demonstration, you would be using, or you should be using the 7 E's model. Right? Since I would assume most of you would be teaching in public schools, right? At least in terms of survey data, majority of SUC graduates would be teaching in the public schools, right? So that's why you would have to learn 7 E's, so that once you're in the field, okay, you don't have to worry about fitting in, since you are already using the topics that the teachers in the public schools are already using. Okay. So what are these different approaches? So the first one is the multidisciplinary and interdisciplinary approach. So what does this mean? So this means it is the use of 2 or more subject areas in one lesson or activities. So for example, we want to connect the science with a bit of history. So that's possible. So for example, we have here Charles Babbage, the founder of computing. We have, of course, Benjamin Franklin, right? He did not exactly discover electricity per se. And then Newton, right? Aside from optics, he also, I won't say discovered, let's say formulated the calculus, along with, I think it's Leibniz, right? So history of mathematics. And who else? Of course, Charles Boyle in chemistry. And then who else? Some of these are not actually familiar. Alright, yeah, Rutherford in the atomic structure as well in chemistry. So what else? Let's say, so that's 2 topics, right? So science, history. Then we can have another example. So let's say, let's add religion or values education. So we can use Copernicus as an example. So Copernicus was a scientist way back in the 14th century, where he was one of the early proponents of the heliocentric model. However, since he was living under a, let's say, strict Catholic Catholic religion, right? And way back then, Catholicism or Christianity rather was very, let's say, hard-headed, right? They don't want to achieve that they're wrong. So they believe that the Earth is in the middle of the universe, right? So that means they believe in the geocentric model of the solar system. As to why they believe in the geocentric model, well, of course, since they believe that humans are the greatest creation of God, that means Earth should also be the center of the universe, right? Because we are the blessed ones, right? We're the greatest creation, etc., etc. But of course, with the advancement of science, with the use of telescopes, observation of movement of stars, that's not actually the case. So what did the Pope back then did to Copernicus? Well, they beheaded him. Right? So they chopped off his head due to, well, fighting or arguing with the church. In fact, it took several years before the church admitted that they were wrong. So from that example, okay, we already have astronomy, right? Due to Copernicus talking about heliocentric model, history, right? Talking about how did people observe planets before or the stars before, and then on religion, right? So what was the temperament of the church back then when it comes to scientific advancements? In fact, science back then was treated as witchcraft or work of the devil or something like that. Okay, so that's multidisciplinary and interdisciplinary approach. You want them to, or rather, you want to connect your subject to different areas. So it could be, so number one, it's for them to poke interest to other subjects, or the other way around. If they're not interested in this topic, you want to know what are their interests. Right, so try connecting their interests to science instead. Okay, then the next approach, we have the STS approach, or the Science, Technology, and Society approach. So it is an interdisciplinary field that examines how science and technology shape societies, culture, and environments, and how social, cultural, and environmental factors shape the development of science and technology. So this is quite similar to multidisciplinary and interdisciplinary approach. However, for STS, this is quite, I would say, a bit more culturally charged. So when I say culturally charged, it is something that they can properly observe, or something that they can realize after several observations. So one example would be this one. So I picked this one since, well, it's CBSE, right? We're in an agricultural school technically. So agriculture rather, sorry. Are you able to hear the video or not?
Yes, sir.
Okay, there's
Yes, sir.
okay.
Yes,
So
sir.
this is quite short actually, just 1 minute. So this is the advancement in agriculture in Switzerland, I think. just music actually. Okay, so in here we can see that agricultural science has advanced to a point that we are using drones to properly manage, well, not just drones, well, the entirety of technology to manage farms and plat lands. So here in the Philippines, we're not yet on this level, unfortunately, right? However, in other countries, since they do have the infrastructure to support this technology, they're able to produce much better quality of crops. And again, we can connect this to our culture in the Philippines that, okay, what is our country focusing right now? We're actually focusing on not on agriculture, right? Which is the saddest thing that is happening in our country. So despite being an agricultural land, from producers of rice, we are now actually importing rice. We are now importing rice. So that would mean that this agricultural lands has been developed into probably residential or commercial lands that would greatly impact the lives of course, our farmers. And then what else? Yeah, it could develop jobs, usually for BPO and such, and for, well, commercial use. However, it's an entirely new kind of worms, right? That's why if we go back to this step here, so examines how science and technology shape society and culture. So unlike multidisciplinary and interdisciplinary approach, where we can use science to English, science to math, STS is strictly connecting science, well, of course, the three letters, science, technology, and society. So you have an entirely separate subject for STS, right? Although that one is, well, a bit more focused on the development of science. But if you're going to use STS as an approach, you would have to fit this for the topic. So let's say, yeah, let's agriculture. Let's lower it down. What subject is in agriculture? You have your chemistry or biology, rather. So biology for crops. And then for crops, you have your non-living things. So living things, right? And then for living things, you have your vegetables. And then for vegetables, you have, okay, what are the different types of vegetables? So you have your different is rice, vegetables, right? So eggplants, tomatoes, etc., right? So from there, how can you connect that to society, right? How does it affect their lives or the development of science? How does it affect the production of tomatoes, etc.? So when it comes to STS, the teacher themselves has to be aware of the different trends in science. Otherwise, you cannot properly explain how it is happening. Okay, then next approach would be PBL, or the problem or issue based learning. So allow students to focus on how and what they will learn. So if they have an unfamiliar problem, situation, or task presented to the students, they are encouraged to determine for themselves how they would go about solving the problem. So PBL encourages students to be self-directed, interdependent, and independent as they attempt to solve the said problem. Now, PBL itself, I cannot cover this in a single, let's say in like 5 minutes, because when I was invited as a research speaker to teach PBL, it's actually quite long. And why is that? Due to this framework. Although it does have a very good output or ways to develop the students, right? Since the students themselves would be the one, thinking of a problem, or if not, you can introduce a problem to them and let them work out the solution. Of course, as a teacher, your goal is to be a facilitator. You would be giving them feedback if their suggestions or their methods are correct, or if they have some inquiries, you can of course answer them, right? You don't. It's not a very hands-off approach. So as you can see here, we have a design element that you can follow. So let's say you want to give them a problem. So it should be authentic. At the same time, you should give them opportunities for them to be heard, right? Student voice and choice. Let them have a chance for reflection. Have them critique and revise their methods or their proposed solution. And one of the, I would say, important part is to make their products public. So this is what separates PBL to other approaches if they're going to make a project. So please take note of the misnomer when we say PBL or issue-based learning. It should be something that they can show. So that's just okay. When you say, right here in the Philippines, we have a mission. When you say project, quote-unquote project, it's something to be submitted. However, in PBL, in project-based learning or problem-based learning, these projects should be shared to the community. So that's the main way to separate a project to a project-based learning. Okay, there should be an audience. So of course, you have there the challenging questions or problems and sustained inquiry. So when you say sustained inquiry, that's not the part of the teacher to always go back to the students, right? Have the discussion be open. As for the teaching practices, so these are actually quite self-explanatory. So build the culture, manage activities, scaffold student learning, assist student learning, engage and coach, design and plan, and align to standards. Okay, so that's our problem or issue-based learning. So again, this is not a hands-off approach. You should still guide student, but at the same time, you should let them be interdependent, meaning it's collaborative, and likewise be independent. So it's up to themselves to use the internet to look for some inspiration on how to solve a certain problem in their community. Now, what about for inquiry-based approach? So inquiry-based approach is quite similar to problem-based learning. However, for inquiry-based approach, I would say this one is much older compared to problem-based learning. So in inquiry-based approach, so it is anchored on the idea of seeking for truth, information, or knowledge. So it is not looking for the right answer, but seeking the appropriate solution. So no one can learn everything, but everyone can learn the skills of an inquiring attitude. So skills, abilities, and habits of the mind to continue learning through inquiry-based approach, teaching and learning. So how do we do exactly inquiry-based learning? So for a method itself, we do have the 5 E's, which we would later learn. Although for the actual process, so this one is quite different from problem-based learning or PBL, right? So you want to, so this is your part, right? So you're the only one who's going to post the questions, but for the other parts, this is what the students should learn. So in inquiry-based learning or inquiry-based approach, there is some semblance of metacognition. So when I say metacognition, thinking about thinking. So if we look at the problems, sorry, not problems. If we look at the questions here, so what do I want to know about this topic? So what do I know about my question? How do I do it? What do I need to know? What could be an answer? What could an answer be? So several questions to let the students think about their thinking. So that's how we let them. Exhibit their inquisitiveness or their sense of inquiry, right? It is not enough to answer a question, but we should also let them think about the answer itself. So as we have said, is it the right approach? Is it the right solution? What are the implications of these answer? So how do I share it with other people? So several questions to arrive to that solution. The next one is constructivism. So constructivism might be familiar in your methods 1. I think this should have been covered. So when I say constructivism, so it is a theory that explains how people learn by constructing their own understanding and knowledge of the world through prior experiences and reflecting on those experiences. So essentially, there is a continuous asking of questions, exploration, and assessment. So if you're going to visualize constructivism, it's a bit of a puzzle, right? But this puzzle in itself is composed of several smaller puzzles. So it's like a two-tiered jigsaw puzzle. However, when it comes to constructivism, we do have actually two theories. So we do have John Piaget's cognitive constructivism, where we talk about concept and principles. By the way, is this familiar? I think in your methods 1, this should have been covered. So are these terms familiar to you, class? So John Piaget, Vygotsky, is it familiar or first time hearing it? So anyone from the class, so is this familiar? So constructivism by John Piaget and Lev Vygotsky. So is it first time hearing it? Okay, I would assume it's the first time. Okay, so for cognitive constructivism, as the name implies, cognitive, so this is all about their knowledge, right? Concepts and principles. But for social constructivism, this is how they're going to interact with other people. So we have here social interaction, psychological tools, MKO, so the peer-to-peer evaluation, the peer-to-peer learning, scaffolding, and the zone of proximal development. Although for zone of proximal development, this is usually in prenatal development, right? So for babies. Okay, so essentially it's divided into two. So knowledge and social interaction. And then next, we have the social cognitive learning model. So again, we do have here a model introduced by Lev Vygotsky. So where he asserts that culture is the primary factor of individual development. So culture teaches the learners about both what to think and how to think. So lessons should be designed to emphasize interaction between the learners and the learning task. So in here, essentially this branches from this one, from social constructivism. So keyword here is culture. So culture teaches the learners both what to think and how to think. And the, I would say, interesting part about culture is that it changes, right? Rapidly, in fact. So just the last 2 years, teaching is online, right? But we are now slowly going to have a form of face-to-face classes. Now, due to the online learning, students actually develop some form of anxiety, right? Why is that? Because usually they're in their homes, they're on the comfort of their homes. They would have the difficulty of interacting with they would have the difficulty in interacting with their classmates face to face. Hence the difference in culture, right? So that means for the past 2 years, there has been a rapid change of interaction between students. So So that's why you might have heard in the television that students have been having difficulties in dealing with their fellow classmates. On a larger disparity of culture, so here we have way back in 1914, right? So early 20th century. So we have here an Ifugao school in the Mountain Province at Cordillera Administrative Region, so in CAR. So this is a photo by Dean Worcester. So what can we notice here? Teaching back then is very teacher-centered, right? And likewise, depending on where they are. So for the Ifugaos, again, I'm not culturally aware of how an Ifugao education is, right? So, but you can see here, majority of the students are male, right? And even way back then, right, during the time of the Spanish era, women are not allowed to study. So 19th century, of course, well, even earlier than 1700s, right? Women are allowed to study. So even right now, there are still some disparity within the Filipino culture, right? Within our different cultural tribes. So what about on the present? So last year, right? So students seated on chairs with plastic barriers to attend a class. So several schools in the capital, Philippines capital, reopened for the first time since the pandemic. So this is in Pasay City, Metro Manila. So that's why our assessments 2 and 3 are going to be face-to-face teaching. Face-to-face teaching demonstration. That's why I want the students to be ready once you have graduated. I don't want the students to be let's say not prepared when it comes to the actual real life scenario. Okay, so what else? So essentially those two, right? So here, within a span of centuries, we can see the changes, or even now, right? So 3 years ago or 2 years ago, changes in education. So today and onwards, there's going to be another set of changes in education. So that's why in the social cognition learning model, I would say this is very appropriate for elementary, since this is one way for them to participate easily, right? Because this is based on, well, on their culture, right? This is what they're learning or doing like 24/7. Okay, and lastly, the learning style theory. So in one sentence, we can say that the learning style theory is all learners, this should be are created equally but learn differently. So this is essentially recognizing Howard Gardner's multiple intelligence theory. Although the multiple intelligence theory has been around for like 50 years, so we don't really use IQ anymore as a sort of standard for how smart a student is. Although for some, we still use IQ, but the let's say the idea behind multiple intelligence theory is that some people learn differently, and plus sometimes if we can say that it's quite humiliating to base a person's worth on their IQ. Hence the push of multiple intelligence theory. Okay, so what are the different multiple intelligence? So of course we have visual spatial, we have linguistic and verbal, interpersonal, logical mathematical, musical, body kinesthetic, and naturalistic. And sometimes there's spiritual intelligence that they added. I think you're already familiar with this one, and I would assume you have already taken a test to know your multiple intelligence theory. Although they said that you have to take this like yearly to know what's your um, multiple intelligence, or whichever you are proficient in this field. In my case, the last time I took um, my multiple intelligence, it was, wow, it was like maybe in high school or maybe even in college. It was like almost a decade, more than a decade. So if I recall correctly, mine is either or both logical mathematical or intrapersonal. Sometimes it's linguistic or verbal, and then bachelor spatial. I'm not really interpersonal and body kinesthetic. Naturalistic depends on my mood or something. But usually, yeah, these two, interpersonal and logical mathematical. Okay, so these are the different approaches that you would have to consider in teaching elementary students, right? So these approaches and theories, this would influence the steps that you are using in the 7Es. Now, what about the characteristics of the scientific and technologically literate persons? So first, they have to be critical and creative problem solvers. So what do we mean by creative and critical problem solvers? Learners have developed skills that enable them to analyze and find solutions to any perplexing questions or problems. It's of course quite similar to one of the attitudes that we have discussed, right? They have to be creative and innovative. Usually, I would say, if I would have to define a genius, so what is a genius? Usually, if you say genius, that is someone with a very high IQ. But I would say, for my own definition of what is a genius, or someone with real talent, that is someone who breaks common sense, right? Because when you say common sense, that is the norm, right? That is what people usually use. That's the standard. But for a critical and a creative problem solver, these are the people who break social norms, or who break the set of standards, right? That's why I would say genius people and people who with talent are people who break common sense. Because when I say breaking the common sense, usually our reaction will be, that's possible, or usually with surprise, can we actually do that, right? That's usually the response whenever someone breaks common sense. So that's why in being a critical and creative problem solvers, they would have to go out of their way to think of new ways. Now, what about for the next part? So, responsible stewards of nature. So, learners demonstrate concern in keeping the environment safe for themselves and for everybody. So, they will become citizens who take responsibility of their action in protecting and preserving the environment. For this one, we do this, or we inculcate this in the values integration, right? Usually by using questions. Okay, how should we dispose of this garbage? Or instead of using this material, what should we use? Let's say instead of plastic, okay, we'll use biodegradable material, right? Usually simple questions to ask or to know if the students are already aware of, well, the basic recycling skills or the recycling ideas. And then, of course, innovative and inventive thinker, similar to the effective and critical problem solvers, they would have to think of a new method to solve a problem. That's why we have a saying that laziness is the mother of invention, right? Because if you're lazy, you want to take the shortcut to achieve an answer. Same thing with here, right? We said, okay, something simple for humanity. So innovativeness would mean they would think of a way that could achieve an answer at the most efficient way possible or at the fastest way possible. Or it could even be both, right? Both efficient and fast. So that is what it means to be an innovative and inventive thinker. Usually, we can observe this in students whenever we let them, well, answer a certain problem without giving them the solution. So you can say, rather we can ask them, how can we arrive at this answer? So of course they're going to give several answers and compare with each other. And lastly, so informed decision maker. So as the science learners are growing up, they should be able to develop the ability to make informed decisions, most especially if they become independent learners. So for being an informed decision maker, again, connecting this to the scientific attitude and values, right? You have to be skeptical, they have to be rational, and they have to be objective. So whatever decision they have made, it should be based on prior knowledge or prior observation, right? So for science, we don't usually go with gut feel, right? We don't usually go with instinct, right? We go with let's say models, mathematical models to propose an answer. So that is what we mean by being an informed decision maker. And then lastly, being an effective communicator. So science literacy also develops the ability of the learners to convey correct messages to others. So whether written or oral, from their fund of knowledge, results of inquiry, investigations, and many more. So there's a need for science learners to share their findings. So not just in terms of sharing findings, they should be able to communicate properly with their teammates. Usually, there's this, let's say, misconceptions that scientists are like, if you watch a lot of movies, right? Usually, scientists are people who are disheveled, with eye bags, rarely come up to their rooms because they are very introverted, since they usually work on their project or experiments. Of course, there's some semblance to that let's say perception. Like for example, I forgot the name. There was this scientist in electromagnetism, right? His first picture was his hairstyle was very neat. It's all combed up, right? And then on his next picture, after like 5 years studying his specialization, his eyes are now deeper, he's paler, his hair is uncombed, right? It's not properly maintained. So yeah, there's some truth to that. However, when it comes to science, usually we're working with different people, right? So that's why it's important to be able to communicate properly to avoid infighting within a grouping. So not just in terms of sharing their findings, right? Okay, so there's that. So these are the characteristics. So that's how we should tackle in teaching elementary science for elementary? Okay, yeah, it's a bit fast, right? Since we're covering topic, and technically, this is in the, well, not everything. Like majority of this would still be from the book that I'm using. Like for example, this one is from the K to 12, but for the rest, it's from the book. Okay, so let's go to the actual spiral progression. So how come science is designed as this way? So when we say spiral curriculum, it helps to minimize gaps in learning. So in kindergarten, as they increase in, as they, what's the proper term? Move up, right? The moving up ceremony, they would be introduced to newer content. At the same time, they would have a much greater difficulty in terms of the content. That is for them to develop new skills so that they would have better mastery. So this is how we can visualize this spiral curriculum. Right, so increasing difficulty as they move up a year level or a grade level. At the same time, they would be introduced to new content, and for the older content, it would be revised so that they would achieve mastery of their skills. Right. So even going back to our table here, this one, right? So performing scientific input skills. The column on the left and the column on the right are quite similar in terms of what they're going to do, right? However, the column on the right, it is much more, let's say, complex in terms of methodology compared to kindergarten grade 4, right? Usually it's counting, picking up samples, but for grades 5 to 8, they would have to follow a certain format, correct measurements. So we can see the discrepancy already in the level of skills that we have to use. Okay, however, as good as the idea of the spiral curriculum is, personally, there is a problem that I'm seeing in the spiral curriculum, and that is the maintaining of information. So let me ask the class, are you still able to recall your grade 7 science topic? So grade 7, that's like first year junior high school, right? So are you still able to recall your probably topic in, is it grade 7? Yeah. Law of inertia. Are you still aware of law of inertia in your maybe grade 7, 8, 9, or 10, or maybe in your senior high school? So do you still recall the law of inertia in your science subject, physics especially? So anyone? Or if not, so you can say you have forgotten. So anyone who recall the laws of inertia? So maybe in the chat, or you can raise your hand. Okay. So do you still recall? So I would assume if you raise your hand, you have recall, right? Okay, so what are those? So Miss Ranyola, so what are the 3 laws of motion?
Ay, yung, about po the, laws of inertia, I've remembered that it is Newton's first law.
Okay, and then what are the other 2? Ano pa yung iba? Kasi di ba sorry, English. So what are the other 2 laws of motion? So the first one is laws of inertia, right? What are the other 2 laws of motion by Isaac Newton? So do you still recall the laws of motion? Right, yeah, it's correct. So the first law is law of inertia. What about the other 2? Okay, so maybe you have forgotten, right? So like what I have conjecture The problem with spiral curriculum is the retainment of the information. Although we could say the same for other topics as well, right? Maybe it is just the, I would say, the design of education in general, right? Okay, and when it comes to K to 12, so we have four major fields in science. So we have chemistry, biology, physics, and earth science. And as for the topics themselves, is this one. So how are they separated? So this is the sequence of domain instance per quarter. So we have, so we're not going to tackle about chemistry. So first quarter is chemistry, second quarter is biology, third quarter is science, fourth quarter is earth and space science. Unlike other subjects, science is more susceptible to the loss of retainment due to this sequence of domain. So as we can see here, how long is the gap between grade 3 matter and grade 4 matter? It's 1 year, right? And the same thing. So there's always a 1 year gap of information. So that means every time you're going to start your topic in, let's say, of course, in elementary, you're teaching all sciences. Let's say you're going to start a new topic in grade 4 Earth and Space Science. So what topic should you recall? Or what should be the recap? It should not be grade 4 third quarter physics. It should be grade 3 fourth quarter Earth and Space. Okay, so law of inertia, laws of motion, right? Okay, so law of inertia, law of acceleration, so law of action and reaction. Okay, so thank you, Darlene. Okay, so going back to the recap. So again, if you are teaching the first topic of the quarter, so your recap should be the previous topic last year and not the previous topic of the previous semester, because how you're going to connect physics to earth science if earth science was taken last year. So that's one of the comments that I usually say whenever I'm checking the lesson plan. Okay, now as for the concepts themselves, okay, so these are readily available in the VLP, right? So I just cropped this. So we're not going to tackle this one by one, but we're going to, well, technically we're going to tackle this one by one by our consecutive meetings, right? So essentially, these are the topics for the rest of our semester. Okay, so far any questions? Or maybe there's a lot of questions. So any questions so far? So course requirements, topics, references, meetings. So meetings, we're going to meet every Monday, right? What else? Okay, so it's okay. Good morning. So it's already 10:30 or a few seconds to 10:30. So if there are any questions, okay, please post them first in the group chat, because some of your classmates might have the same question. Okay, so group chat first before any personal questions. Okay. So this will be ending our class here. So again, if there are any question, group chat first. So see you next